Right, so in this video we're going to be taking a look at projectile motion. So projectile motion itself is basically when an object moves in a parabolic shape, as I've drawn here. The projectile itself has no source of its own force and can just basically be a piece of paper like this, or scrunched up flying across the room, or it can be, for example, a paper airplane just going across the room. What we're going to do is we're going to analyse the speeds of it and the time it takes to actually get start its journey at ground level over here and then return back to ground level at this point over here. So the first thing that we're going to note here is that anything going upwards, I'm going to treat it as it's a positive value, and anything going downwards, and we're going to treat it as a negative. So that's the first thing we're going to say. We're also going to assign some angles and speeds onto this one. So we're going to say that angle in there is actually 25 degrees, and the speed at which it moves off, so we're going to call this u, the initial speed it moves off with is going to be 15 meters per second. So it's actually quite simple. We're going to actually analyze three different aspects of this. We're going to analyze the range of it. So I'm going to call this x. We're also going to analyze the total flight time, so t total. We're also going to analyze this height over here, the vertical, or the max vertical height as it's sometimes called. So we're going to call this S. So that's what we're going to analyse for this projectile motion question. Obviously you can tell straight away that this problem has got two different parts, and they are a reflection of one another. It's just everything is flipped over on the other side. So this is part one of the journey, and that's part two of the journey. We're going to analyse both parts of this. So to begin with, whenever you have a vector like this, what you need to do is you need to resolve it into the horizontal and vertical components. So that's exactly what we're going to do. We're going to say the vertical component is going to be 15 sine 25, and the horizontal component of this is going to be 15 cos 25 degrees. So that's that resolved. The next bit, we're going to analyse the first part of the journey. So in this first part, we're going from this point to this point, and we need to note here that we're only concerned with going upwards. It's almost like throwing a pen up and then catching it. That's all we're analysing, because we cannot, the vertical and the horizontal would never actually, they're both independent of one another. So that's exactly what we're going to do. So we're going to say 15. We're going to start off with the UV on this side. So we're going to say it starts off with UV, and over here we end up with a position which is going to be called VV. And as you can tell, when you throw this pen up, the split second it's right at the top. We've got a 0 meters per second right at the top, and UV is actually what we've just worked out over here. That's UV and that's UH. So we've got UV and VV. And what we're going to say is we're going to say V is equal to U plus AT. We're going to rearrange this. We're going to say V minus U all over A is equal to T. And we're just going to put on. Right, so what we need to do is we just need to put our values in. So we're going to call this VV UV. So VV is actually 0 minus UV, which is going to be 15 sine 25. Divided by negative 9.81, and it's negative because anything coming down, and gravity in this case is coming down, is going to be negative, so we can work that out. Right, so if you run this through your calculator, you should get an answer of about 0.65 seconds. The next bit of this, we're going to move on to part two of the journey. So that's this bit, and in this bit we're going to begin with actually UV this time, which is actually equal to 0, because remember, if you throw a pen right at the top, the speed right at the top, the instant it's right at the top, is actually 0. So UV is 0, and all the way down here we've got a speed of VV, and we can work that out. But we're not after that, we're after the distance S. And in our case, we can work that out because now we've got a time taken to get to the top. We can also work out the t total actually. All we need to do is just times that by 2, because 0.65 seconds it takes to get to the top, and then another 0.65 seconds to drop. So we times that by 2, we get 1 point times by 2, and we get 1.29 seconds is the total flight time. Right, moving on then, part 2 of the journey, we're going to work out this distance s, and s, we're going to use one of the SUVATs, s equals ut plus half at squared. U in this case is 0 because we're right at the top, so therefore we cancel that out, and it becomes s is equal to half at squared. And again, we need to just put our numbers in, so 0.5 times by 9.81, can be a negative or positive, because this distance, it doesn't really matter in this case, so I'm just going to call it a positive, times by t squared, and t is 0.65 squared. So we can run that through a calculator. Right, in this last bit we're going to calculate the x distance, and x is normally given by uh times by t, and this is basically the distance, which is given by s is equal to the speed times by time, and what you'll find is meters per second, which is the units there, times by seconds. You'll automatically see that seconds and seconds cancel out and we're left with meters. So that's why this works. And all we need to do again, we just need to take into account the the horizontal distance this time, because remember, they're independent of one another. So this time it's just 15 cos 25 times by the total flight time this time, because we're going from this point to this point. We're taking into account all of the journey, 1.29, and we get an answer of 17.54 meters. So that's the x distance. So there you have it. That's how you solve a very simple projectile motion. All you do is you split your speeds up into horizontal and vertical components and then work off that. Thanks for watching.